So here's our next example. And so we have our same input we had last time, which again is realistic. The most common input in industry is the step input. Turn the machine on, at some point, turn the machine off. So total realism here. Uh, and so here now we have the impulse response. And so it's a little more realistic. We can imagine you hit something with an impulse and it starts to scream, and then and as the pain dies off, it falls off. So it looks a little more realistic. So here we have this ramp, and you notice I'm noting what the equation looks like. So from here to here, starting at 0, this looks like 2t over 3. And then this, if you let that go up, it would go up to 4. So the equation in this region is 4 minus 2t over 3. Okay, so we're going to need that as we move forward. So we're going to now do this and do the integral for batches of time at the same time. What am I saying here? For example, so picture here's this thing. I take this input and I flip it. So I have the first input coming through with the other remaining part lagging by 2 seconds. And I let it start to intersect. Okay, maybe I'll just suppose this is my eraser. So I'm going to let it start to intersect with the remaining part of the input staying on the outside. Well, as I let this thing slide, how far can it slide before I have to change my equations? It can slide 2 seconds, because once this front edge gets up to 2, the back end is now coming in. If we go any further, there'll be an empty space. The initial part of the response, the impulse response, is no longer getting excited. So, first thing we do is draw a picture. So here we have the impulse response, and I'm going to let t go from 0 to 2. So I just draw a represented picture. So this is t is up to 2, and here's the back end of the input at t minus 2. All right. And so here we have our equation. Now notice my input has a height of 1. So this is kind of boring. It's a height of 1. If I multiply this and this together, I get all zeros here, 1 times this ramp, and then if we go beyond this, I have no input, so it's 0 times all of this stuff is a 0. All right, so in this region, the input is a 1, and at any given tau in here, okay, this is the equation of this line we said was 2t over 3. Well, we flipped that into a tau. This equation in here is 2 tau over 3. Our scale here is in tau. Okay, so I stick that in. Input's a 1. I have the corresponding impulse response is 2 tau over 3 for any time tau from 0 to t. If I integrate this, I get tau squared over 3. This goes from 0 to t. And so when I evaluate this, I'm left with t squared over 3. So in the first 2 seconds, my response, I'll just stay here, is simply t squared over 3. So take any time you want from 0 to 2, and that is the response. All right, so once I get up to time 2, this back end is now in there, and I've got to account for that. So I'm going to go now from 2 to 3. Why am I doing that? Okay, well, I'm starting from where I ended last time, so that makes sense. But the problem I face is that as the front edge hits 3, my equation, here I call that 2t over 3, well, it switches. Now I've got, starting at 3, the front edge is going down the other side, which will have a different equation. So I can only go to 3 because I hit a corner here. So every time one of these corners here intersect, so we have 1, 2, 3 corners here, and then I have 2 corners to my input, I got to redo the equations. So that's another reason you draw stuff so you can visualize where stuff is going and go, when do I hit something? Because then I got to redo my math. So again, we draw pictures, and we got more information than we need here for the moment. Let's just take this away. So as we go from 2 to 3, here's the front of the input going from here to there. And here's the back end of the input. It's inside, so there's going to be a zone that has no response. So if here's t, this back end is at t minus 2. Whatever t this is, this back end is t minus 2. All right, so now we want to integrate this. So we'll notice from 0 to t minus 2, there's nothing there. Then I can go from t minus 2 to t and finish my integral. And that's what I have. So from 0 to t minus 2, the input is 0. The impulse response is 2 tau over 3, but it doesn't have anything to get happy with. So that does nothing. Then I go from t minus 2 up to t. Everywhere here, the input is 1. And as we go across, as a function of tau, the impulse response is 2 tau over 3. So we just multiply them together and integrate. The end result, we have a t squared over 3 here, but we have a minus t squared over 3 in here. When you go through all the math with this t minus 2, it all settles out at 4/3 t minus 1. Now, note, if I put 2 in t equal to 2, I have 2 minus 1 is 1, 4/3. If I put t equal to 2 in here, I get a 4/3. You can check your work. The last point here had better match up with the first point there, or you made a mistake. All right. So now, what's the next thing? As I let this, once this front edge hits 3, I can start sliding along, but when I hit 5, this thing that's 2 seconds back is going to hit this corner up here, right here. So I can only go up to time 5. All right? So now we draw a picture of what we have. So we're going up to time 5. Here's t. Here's time t minus 2. And so if you look at what we have, the input's always 1, but we have a split happening here. I can go from from 0 to t minus 2, there's no input, so that produces nothing. I can integrate from t minus 2 to 3, where this is 2t over 3, or 2 tau over 3, and then the rest is 4 minus 2 tau over 3, this piece up here. So what does that math look like? If I go from 0 to t minus 2, because there's no input, it's all a 0. Just wipe it out. Now, I go from t minus 2 to 3, input is 1, and the impulse response is 2 tau over 3. Then I jump from 3 to t, which is the rest of the way out. Input is 1, but now we switch to this equation, 4 minus 2t over 3, or tau. All right? And we integrate it. And I'll just leave it to you to check this out. We get the following equation. So that's going to be sort of a parabola kind of thing, turning down. All right? So now we go, let's see, as this thing moves ahead, when this thing hits 5, the front end can keep going until it hits 6. And then the first input's done. It starts to leave. So once we hit this corner, boom, got to stop. When the front corner hits this corner, you need 2 corners to hit, you have a problem. So we'll stop it, we go from 5 to 6. That looks like here. So this thing is going up till it hits 6, and this is always 1. And now we're going to have this zone here from 3 to t minus 2, there's nothing there. In fact, from 0 to t minus 2, there's nothing there, so there's no response. So I just wrote this as 0 to t minus 2, wiped it out, there's nothing there, no problem. Then I have from t minus 2 up to t, this is height 1, this is 4 minus 2 tau over 3, integrate it. And we'll note this is symmetric with this. And that makes sense. As this candle came in off the corner, that's this one approaching the corner. It's symmetric. So when we go to plot this out, this and that better look symmetric. All right, on to the next page. And we have our last piece. I'll let this all suppose. So we ended at 6, so now we're going to start at 6. And we'll let this front edge keep going. There's no interaction here, so there's no response. You just get a response to the portion from t minus 2 to 6. But at t equals 6, the back end of the input hits the end of the impulse response. Then we're done. All right? So the input is 1 everywhere. From t minus 2 to 6, we have 4 minus 2 tau over 3. Multiply them together, do the integration, we get this. Okay, and so that'll be symmetric with our initial time when we came in. And if you went beyond t equals 8, there's no input interaction with the impulse response, output is 0. And here is the response plot of everything we had. We go up to 4/3. If we check what we had here, this would start at 4/3 right here, if you bother to put in t equals 6, and it falls out. Here we are at 8/3 at 3 and 5, and the top. This 10/3 should be up here at the top, so that's a little off. I'll fix that here in a moment. I have one more set of problems to do for you, and we will be done with convolution. Have a good day.